visualizating. I don't think that's spelled right. It should be visualizing. Visualizing the hook methods. Visualizating. That's like Shakespeare. He made new words all the time. That's my new word, visualizating. So what we're going to do now is we're going to visualize the functional solution using streams. And then, of course, we're going to look at the implementation in the next discussion. So here's what it looks like. We take a list of input strings, which are the work of Shakespeare. We convert that list of input strings into a stream, a sequential stream, of course, of input strings. That outputs a stream of input strings. So you can see we still have strings. We then go ahead and call the map method, passing the stream of input strings into map. And so every input string will go to a different call to processInput. ProcessInput will search for the phrases in a given input string. So for each input string, for every input string in the stream, processInput will be called to look for the phrases in that string. And that, as you'll see, will return a stream of lists of search results. And you can see I visually show that we change from a stream of strings, so that's the icon for string, just have some shape and some color, and we end up with a stream of lists of search results, which is those things. Now, that output is then obviously going to have a different type. So you can see how, in this case, the processInput method used by map transformed the type of its input stream into a different type for the output stream. And that's one of the things map is capable of doing. It makes those conversions. At that point, we then feed the list of search results, the stream of lists of search results, into the collect terminal operation. And remember, one of the things that a terminal operation does is it triggers everything else to run, so that'll actually cause it all to start running. And it's also going to go ahead and convert that stream of lists of search results into a list of search results. So you'll have a stream of lists of search results converted into a list of lists of search results. And the ordering of that list is based on so-called encounter order. And encounter order is just the order in which things were encountered, which is just whatever the person wanted to make the works of Shakespeare show up in. They could be ordered, they could be sorted by date of creation, they could be sorted by the name alphabetically. We don't know, we don't care. But that's the order in which we get the results. Here's the processInput method. So we looked at processStream. Now let's take a look at processInput. So processInput creates a stream by taking a list of phrases, which are strings that we want to find, and it converts it into a stream of phrases. So we have a stream of phrases, a stream of strings. We then go ahead and input that into the map method. And you can see here that map is going to have a lambda expression. And this lambda expression, as we'll see when we go into it in more detail in the implementation part, is going to search for the phrase in the given input string. So for every phrase, every phrase in the stream, we're going to search for that phrase in the input string. Now, that is going to end up creating a stream of search results, one search result object for every phrase we search for in a given input string, a given work of Shakespeare. And in this particular case, just for kicks, we're going to filter out anything that was empty. So we didn't do that with the other example, just to make it different. But in this case, we're going to use filter to get rid of search results that are empty. So if somebody looked up, neither a borrower nor a lender be, and they looked it up in Midsummer Night's Dream, that phrase doesn't appear there, so we wouldn't have any matches for that. So in that case, we would filter out empty search results. And if there's no matches, or whenever time there's not a match, then we're going to have a stream of search results where the elements of the stream will be matches that actually were found in that work of Shakespeare. We then call collect. That triggers the intermediate processing, and it converts the search results, the stream of search results, into a list of search results. And it might, in fact, be a list of empty, or an empty list of search results, because none of them may have been found in a given work of Shakespeare. So keep in mind that that list may be empty, and that will become important later. And that's because we'll talk about what we're going to do if we end up with empty lists of search results. And we'll talk about that. That's going to be done a little bit later by the print phrases method. And the print phrases method, not to get too far ahead of ourselves, is going to end up using something called the flat map aggregate operation or intermediate operation in order to automatically remove all the empty search results. So we wanted to do that just to show how that feature worked. Okay. So obviously we're focusing on sequential streams in this example, and we'll talk about parallel streams later when we talk about parallel streams. And the cool part about this, if you take a look, is that there's just a minuscule change to go from a sequential stream to a parallel stream. All we have to do is just make that change here, and boom, everything runs in parallel. And as you'll see, or as we talked about before, that speeds things up quite a bit on a multi-core processor with very little effort. And that's also, by the way, one of the themes that you should get from assignment 2B, which is how trivial it is to change from a sequential implementation of the image crawler to a parallel version by just making, one or two little tweaks to your code, which is really cool. All right, so that's the hook method visualization discussion.